which is totally unknown to me. If possible, I will talk something about C graphics, which or other extension of that you will get in your next semester in AutoCAD class. But anyway, let us start. Today's topic, as you know, is array and function pointer. Rather, we discussed about function pointer already. So this is the topic we discussed in the last class, and somehow you have seen that a function pointer is defined like this, okay? The output type, this is the pointer to a function. So you understand asterisk is the pointer, and when this is enclosed in a parenthesis, you understand that this is the function name, okay, to which it points, and this particular one is the argument of that particular function. This is the logic. And then there was an example. So that particular example we couldn't discuss in much detail. Here you see the function pointer here is this tabulate. This is the function pointer, and what is the name of the function here? Function pointer, this is f. Okay. So that f has argument of type double, which has a return type double as well. Okay. And then the list other arguments of the functions are this first, last, and increment. All are of the type double. Okay. So here, as this is a function pointer, this points to any function which has this particular form. Okay. So here you see the particular function here is taken as a sine function and as a cos function, which are already defined in this math.h or math header file. So you have to see what are the type of arguments and the return type of this sine and cos function, which you can find out by opening this math.h header file. So for any header file, you can locate the header file in your compiler or that IDE, and if you click it to open, you will get a list of the functions available and that function declaration part. Okay. So that means this declaration part of the function, okay, that much you will get. What is the declaration part? The detailing part is not available, so that you won't get within this header file. It is inbuilt within the compiler. So the sine, cos, all of them has this particular type, return type double. Type is double, and this particular arguments are the arguments of this tabulate function. Okay. So what are the arguments in this tabulate function, it has a function pointer, and these are the list of arguments here, or list of parameters. Okay. So that definition of the tabulate function is given here. And where is our main? This is the main. Okay. And in the main, you see, the function tabulate is called here with this function cos. Okay. So the definition of cos is already there within the math header file. So that part is not required, but you have the option of creating your own function, and then you can call it by using this function pointer. So these two lines which are right now commented, there you can change this cos by sine, and here also in tabulate function you have to change this cos as sine. So if we run this program, this is what we will get. This is the example when we are using it with cos, and this is another example when we will run it using sine. You can change this initial value and final value. Okay. Actually, if you run from 0 to 2 pi, you will see that for sine it will start from 0 and again it will go up to 0. In between it will cross some 0 value, whatever. So the sine wave and cos wave you will get completely. So that was example of function pointer. The next part is array pointer. So now recall that when we discussed about array, these are the recapitulation part. Array is a collection of similar elements, and we will extend it when we need to club this similar object. We will be discussing about structures afterwards. So array has a particular data type, a character, integer, double, whatever. Now array name here, this is important, that array name itself points to the third or zeroth element of the array. Okay. So for any other variable, right? So here, say for example, this x. Okay. This x is a variable. Double initial value by, no, this is within printf. This is not a variable. You see here, this double final increment initial. These are the variables here. Okay. And to locate the memory address of these variables, we need to find out the memory address by using ampersand final. That will give the memory location that you know. Okay. But in case of an array, the array name itself, it points to the zeroth element. Okay, and as in the definition of array, we already know what is the size of the array. So we know, starting from the zeroth element, how much of space this array will take, and then starting from that particular position, we can find out location for any particular element. Okay, this is what we have seen in our previous lecture. So if the type of array elements are short integer, which takes up 2 bytes of space, and we have an short integer array with 8 elements. Okay. So these are the 8 elements to understand, starting from 0 up to the 7. So for any particular element I, that we get from this A0 plus I into ND. ND is basically size of the third integer. So here this is not required. The compiler does this thing. So what we have to write is simply the A, okay, A0 plus I. So this I, when I is 1, that means from here it is coming to the next memory location. Okay. So this ND, this is known to the compiler because the array type is already declared. If it is a int, this value would be 4. If it would be a double, this value would be 8. This we know. Also, we know that there are different types of array. These are one-dimensional, two-dimensional, three-dimensional, etc., etc. Now, note, when we say an array name points to the first element, this is sacrosanct for a one-dimensional array. But what will happen for two-dimensional and higher dimensional array, that we will see afterwards. Okay. Right now, let us consider one-dimensional array only. And then let us see some of those array functions or use of arrays which we didn't discuss earlier. When we were discussing arrays, okay, we discussed only some of the examples, and remaining ones we didn't discuss. So that part will be clear now. So here you see an example where array is passed by using array pointer. Okay. So here the argument of a particular function is an array. Let us see. What is that particular function? Say max is a function. This is the function declaration. Output type is int, and the list of parameters here. This is an array of type integer. Is clear? And this is another argument which is of type integer. Usually what we require is that when we pass a particular array by its 0th element, so the array name itself is the pointer. So the array name will point to the 0th element. And if we know the size, that means if this 8 is known, then we can pick up any element from this array, because this is what we know already, and using this we can get any element of the array. So to understand that, to pass an array, you need to pass the name of the array and its size. So here this indicates we are passing an array, okay, type integer. And this integer is obviously, although it is not written anywhere, is obviously the size of this integer. It has to be. Otherwise it cannot work without this information. Okay. But you know, there are other high-end computational packages like MATLAB, etc., where this is not really necessary, where you can decipher the size of any type of array, one-dimensional, two-dimensional, three-dimensional. There are some commands or functions there, size, length, etc., by which you can pick up the size. But anyway, like C is one of the basic language. Your AutoCAD package is also based on C language. Your MATLAB computational software is also based on C language. So they added some more features to it, and there this type of information is not needed. You can only pass the array; it will pick up the size of its own, whatever. So this is the definition or the declaration of a function. The definition of this next function is given here. Uh, anyway, let us see the definition part first. This is matching, okay. Output is in, input, so here name of the array is A, its size is obviously n. And here the purpose of this max function is to find out the maximum elements of this array. Okay. So we start with a very low number, and actually, by taking a, whether it is, I think for a 16-bit compiler, this is the minimum integer value that is available. So that is assigned to an integer variable n, and I is another integer variable. So that is used within for loop. So what is there in for loop starts from 0.
Sir,
Right.
sir, one buzz sound is coming in the background.
Just a minute, I understand. Hello, that noise is still there?
No, sir. Now it is okay.
It's okay. Okay. Okay, let us go back there. Talking about this. Okay, we are talking about this particular function. So you see, this is a minimum integer value possible, and it runs up to n. So you understand n is the size of this array. And it is incremented by 1. So what we are getting from here, this AI, okay, what are the values of this AI now? Starts from 0, A0, and it goes up to A, I minus 1. Right? So you see, if we have 8 elements, we start from 0 and we run up to I minus 1, which is 7. So we are covering all the elements of the array. Okay. This is what is happening. And what is the logic here? So if this current element of the array is greater than m, then this m becomes the current value. Okay. So when this entire numbers, they will be scanned, what we are having is the maximum value which are present in this array, and this is returned. Now in the main, what we are doing is, say we have created an array, and the elements of this array, they are read from the input device. Now here you see one thing, this ampersand, this is used in connection with all these elements. Okay. In general, this array name locates this particular zeroth element, and to get the memory location of any element, we have to refer it by this ampersand AI. Okay. So gradually it is taking up all the elements of the array. So now when this is complete for I equal to 0 to size, okay, size is 5, and this size, this is what is the argument to our max function. Okay. This is the size and this is the array name. So this is the calling function, and this is the call function. So in this command, in this line, execution will shift from this max to this point, and this return value, it will stored in this M, and it will print max value is M. So this is clear. So this is what you will get, not required anyway. So this was the input values 1, 2, 3, 4, 5, 6, 7 anyway, not matching with this, but still this is what will happen. Okay, this is an example of passing array element or array to a function. Another one was, there's the same thing, right? It is the same thing. And then we had that particular example of mean, median, and mode. Here, these functions are defined within the main. So the functions become internal to the main function. So let us focus on mean. We have a function mean. You understand what is mean. So instead of max, what it will calculate is the mean of these values. So if you have an array of any n numbers, it will calculate the sum of these n numbers, and it will divide the total divided by the number of terms, so we'll get the mean. So this is the function declaration, this is function definition. Here again, we have a size. Int m is the size of this array A. Right? So the elements of the array A, this is read from the input device. You understand here, this is read. Also take a note that in this program, a particular array is initiated with size 100. In the previous case, we had used a variable size, right? Used a variable size to control that. But here, this is pre-assigned as a value 100. So as if we do not know what would be the size, and we do not want to read this from the user. So this is a predicted value that no one is going to give an array of size higher than 100. Okay, so in this connection, we'll see afterwards how logical is it, or when it fails, what we do. These are some points here. So this is definition of mean function. You understand almost same thing. So we initiated an integer here, which is 0. And then what we compute here is the summation of all the numbers. understand this is sum equal to sum plus ai. Initially 0 and I runs from 0 to m minus 1. So we are adding all the numbers and the return, you understand, although this is integer, sum is an integer. This number of terms m, this is integer. But this division will not be integer as such. Say sum is 14, m is 5. So if we make an integer division, then sum of the value that will be truncated. We'll get a value of 2, where 14 by 5 is actually 2.8. Right? So this is a typecasted using float. And this should match with the return type. So this is returned, and what is returned is basically the mean value. So where it is used in the printf, actually it is directly printed in this main program. So this is the mean, and this would be replaced by the return value of this main function. Okay. That is here. Median part, calculation of median is not shown here. In our previous array slide, the other two functions, median and mode, those modules were there. You can see them. So this is example how we pass array element to a function. So this is quite easy. Only thing is, only the name of the array is sufficient. So that you understand. Now next part is here. So this was up to this point. We had array of one-dimensional elements or one-dimensional array. What will happen if we have an array of two dimensions, which is called a matrix, you know. But you also know that if computer, there is no distinction between array and matrix. Because a computer memory, it will not store the memory like a tabular form. What it has is only a memory table like this. Sorry. So also recall that we discussed about the storage of this two-dimensional array. So there are two formats which are used in different languages. They differ actually. So as we are discussing about C, so the format for C is row major. So what is row major? To understand, the row major is like this. For a matrix, first row is written, thereafter the second row is written, thereafter third row is written, like this. They are written in the memory. So memory, this is a continuous block of memory address and memory location. There we cannot make a tabular form, we can put one above the other. That is not possible. So this is what we use in row major, and you understand in column major, we would have stored first this color, then this color, and then this color, etc. So whatever. So if we have a 2D array, say the name of the array, what is the size? No, whatever. There is a mistake. Here it should have been 2, 3. Say there are 2 rows and 3 columns. So it will take automatically 1, 2, 3 as the first row and 4, 5, 6 as the second row. So what will be the format in this memory here? Is it identical with an one-dimensional array? Okay. Although it looks like an identical one, but the compiler keeps a note that this storing is for a two-dimensional array. So this particular one is stored as a single row first, and then this is the second row. It should have been 2 and 3. So 2 rows, first row, second row. Each row contains 3 columns. So this is what is stored. Now you see the situation has become different. Now can we find out a particular element like this? That is not possible now. Okay. This is not possible now because here this is a block, this is another block, then we have another block. So this is an array of not integers as such. Rather, this is an block of integer arrays. How many arrays? Here, 2 number of arrays. So what the name indicates now, it gives location of the first element or the 0th location of this particular contiguous block of memory. Okay. So what would be the next location of memory in such a case? It would be this particular location. Is it not? Because now this is an array of arrays. There are 2 number of arrays here. It depends on the size of the matrix. If there were 3 number of rows, so there would be another row. So the next memory location would be there. Okay. So this is the difference in finding out the particular location of an element from our memory block. Now the question is, so if this is the case, how can we get back a particular element? Now, you see, what we have to do is, this is pointer, a first location of pointer, then this pointer location plus 1 will shift here. And if we put another pointer in front of it, then where it will go? It will go inside. And on that, if we'll add the number of columns running from here 1 to 3, we'll get back these particular elements. So that way we have the option of going inside this particular sub-block or sub-block of array and find out the array elements. Okay, this is the logic. Got it? So pointing two-dimensional array is a bit different. Pointer to multi-dimensional array. So this is whatever is explained here, how we get it. The pointer to pointer, if this array is our two-dimensional array, then this plus j is the column number. Okay. And that way we can find out what are the particular elements in that two-dimensional array. So these are some of the references which you can use. So this is some of the topics involving our array pointers, right? Now, in this connection, let us focus on that once again. This size here, here we had size 5. Here we have this array size as 100, right? So as I mentioned, this is in general not known a priori. We use our logic or our experience to allocate this memory size. Now there is another technique by which we can control that part also. So in that connection comes this idea of dynamic memory allocation. So this dynamic memory allocation, this is used to allocate, deallocate, or reallocate the memories. Actually, there are 4 functions in connection with dynamic memory allocation, out of which this malloc and calloc, they allocate memory, and this free, it deallocates or frees the memory, and reallocate, it reallocates the memory once again. So these 4 functions, memory allocation functions, they are library functions, and to use them, you have to include the library, stdlib.h. So without including this particular header file, you cannot use this uh, memory allocation functions. And these functions are known as dynamic memory allocation. Now, reallocate part we won't discuss. We will be discussing about allocation of memory. There are 2 methods. One is calloc, one is malloc. The other one is the free. So when use of memory is completed, we can free it. Okay, this is the thing, and let us see how we do it. Now, what we'll be using here is basically allocation of memory for array type, okay? But the memory allocation, actual use of memory allocation is only for array variables. Rather, they are more prevalent in connection with structures. Okay. Because in structures, what happened, we create our own data type, you see, and that data type contains some elements, okay, which are known as the objects, and some of those objects, they need to be eliminated from our data structure. So this structure is the starting point of data structure, which is handled in business application. Okay? Data structure is altogether a separate topic, which is taught in computer science. This is not in the domain of mechanical engineers, but there we need to create some new members of that particular object type, or sometimes we need to eliminate or delete some of the members of that object. For example, say a particular bank has a register for the account holders. Now I understand when someone comes to open an account, it has to add that particular account in its list of account holders. So this is creation of a new element, and when someone closes his account, he takes out all the money and closes the account. That particular account has to be deleted. So such type of application are much more serious application than the type of memory allocation of an array. So this memory allocation major use, the primary use, uh, uh, pointers to create dynamic structures. Actually, you see, this memory allocation is possible only through pointers. Okay. And here, use of pointers to create dynamic structure means that type of example that I have told you, account holder, which we need to control dynamically. We'll delete some of the element, we'll add some of the element. These are the part of that linked list. I am not aware of that. Again, that idea is needed if you need to know more about data structure. So this is major application of memory allocation. So that part we will be discussing here. So this is what is the major use. So let us not discuss here this thing further. So these are some of the idea, create data structure, linked list. Let us come to our discussion on memory allocation for arrays. Here, there are two primary methods. One is malloc, one is calloc. Let us see what are their difference. That calloc provides a chunk of contiguous memory. Use this for creation of an array. For most situations, we'll use malloc, which has the form. Let us see what is the form of this calloc first. So here, this is a pointer. This pointer means this is the memory location where the additional space is created. This type is the type of data, and you understand this is the pointer variable. So this is like say int star. Let's say pointer to a integer type of data, and how much of memory will we require. This is calloc n. N is the number of blocks or size of the array. Then this type, it can be integer, short integer, long integer, double float, whatever. So this is usually written as size of type. So if it is double, we will write here size of double. In that case, what will happen? This will become compiler independent. Whether we are using 16-bit, 32-bit, whatever. Okay, so this is the practice. Instead of specifying explicitly the size, we use size of function, inbuilt function, or this is a keyword, I think, C keyword. N is the number of blocks or size of arrays. If this is 8 and if this is double, how much memory is created? 8 into 8 is a byte size of double, and say if we say this 5 into 8 is 40. So 40 bytes of additional space is created at that pointer location. Okay. Now, what is the use of malloc now? Here you see pointer, the same thing, this pointer. This again, the type of uh, data for which memory will be allocated. This is malloc and size of type. Okay. So here in malloc, we are not allocated this block of memory space. This is only for a particular type. Okay. So this sets pointer to point newly allocated chunk of memory, that is the type specified and the size needed for that type. So for a single variable, we can use malloc. For array, it is better to use calloc. So this is only the difference. Their structure is almost identical. Only this parameter n, or number of blocks of a size of the array, that is additional part in calloc. So you understand malloc and calloc both are used for allocating memory within the computer memory block, and you must be knowing that these spaces are allocated in heap. So that is why if those are retained there, then the heap gets overloaded. And I have discussed earlier somehow there is some overflow problem. Nowadays there are so much of memory it doesn't come, but still it is a better practice to make the space free when it is no longer in use. So another C instruction is free to free up allocated memory when you no longer need it. In free pointer, that means this is free. Pointer means this particular pointer which we have already created to allocate memory. Then it is also possible to free some existing memory also, which are not created by using malloc and calloc. Okay, there are some examples also how to create them. This is not shown here, example of calloc and malloc. So that total, this in totality, this code is available elsewhere. Okay, whatever. I am not going into that details. And then comparison is fine. Okay, there is another difference that in malloc it creates some memory, but it is not initialized. Okay. Whereas in calloc, the memory space is created and it is initiated at value 0. So creating memory using malloc and not assigning anything means if we use that space of memory sometime by error, it will give some garbage value. Okay, this is what we have already seen, return value. Okay, so this is also important. This need to be checked. Okay, so if this is not successful, that means if this particular command or particular instruction for allocating memory using malloc or calloc is not successful, in that case, the return type will be null. So that here is it shown. It is not shown here, but it is possible to keep a check in the program code such that if this null value is returned, then some error message can be displayed. So this is a useful information which we get from the scalloc and malloc. Then what? We already know about size of. This is also known. Okay, whatever. I'm not going to discuss, but one thing what we see, this is also possible. That means, unlike calloc, in malloc also, here also we can put an integer value and multiply this thing. So instead of this n value here, this we can also use as it is shown here. You need to try and see whether it is successful. Probably it would be successful. Okay. Like this. In that case, malloc and calloc becomes almost same. So whatever, this is RAM idea about dynamic memory allocation. Right? So that is all up to dynamic memory allocation. This is fine. So in the next week, we will be discussing the remaining part, the structures, the enum. Union is a minor thing, like a structure, linked list, and this macro we'll be discussing. This is a part of that key processor statement. Okay, something about macro we have already discussed. That we can discuss once again. Enumeration part we'll be discussing, and this is command line algorithm. This is not used ordinarily in Windows operating system. In Unix system, this is used much, which is mainly text-based system. This is also not be discussed. I am not aware about Unix operating system, so this command line algorithm I only used to discuss. Linked list and CLA, that part I will be discussing. And then the next week, so next to next week, there would be two more tests. One would be a shorter test, one would be somewhat a longer test. Or what we can do, we can take a particular test on that week, and I can give you some idea about C graphics.
So next to next week.
Because next week we will be discussing about structures, unions, this macro and enum. So
Okay,
we'll be
sir.
requiring 2 lectures, and next to next week there would be a test, and in the other class we can discuss about C graphics. Although it is not part of your syllabus, so I think you would be interested to know about it. You are already doing a course on your engineering drawing, right? You are. I think you did it in your last semester engineering drawing. Now you are doing descriptive geometry, right?
Yes, sir.
The type of curves and other things, that part is possible to generate by using C language, because those curves has an equation, and if you have an equation, you can write a function for that, and whatever we'll see if it is possible. Even solving of some of your this descriptive geometry problem. Okay. That is also possible by using this C program. Because you know, in descriptive geometry also there is a mathematical basis of everything what you are doing there. Although the basis is somewhat different there, because you are familiar with using XYZ reference axis. You are not familiar with using HVE plane as your reference plane. That is what makes everything quite difficult. But if you understand, this is the same thing. Instead of taking lines as reference, you are taking planes as reference. So if you can find out what is the mathematical basis of that descriptive geometry, you can always solve the problems, descriptive geometry problems, by C programming. So whatever, if possible, I will see it. Ajay, by the way, I have another question now. So all of you are using C compiler in a laptop or desktop?
Yes, sir.
All of you, right? Because C graphics is not possible, not at all possible in mobile phone. So this is a good part. And what form of this compiler you are using, you need to install some add-on in this particular compiler, because here you cannot use graphics directly. So that part is required. So that I will be talking to you, and if possible, some modules that if it is available, I may share with you also. Okay. So that part will be discussing. Okay. So anything? Okay. Any questions today? Any more question? Raju, how was your exam? Raju Bourbon.
Yes, sir. Good, sir. Thank
Okay,
you, sir.
bye. Okay, bye.
Thank you.